So we'll start, right? So first of all, I just want to show you something. Okay, just give a minute. I hope my screen is visible, right? You can give a thumbs up. No need to like unmute your mic. Okay, great. So after we are done with this DBMS syllabus, right, and the mock interviews, right? So what we'll be doing, we will be starting with. I am just taking some classes right now, so just I wanted to let you know that what will we be doing, right? So these are backend development basics. Since I'm a backend engineer, so it's kind of my initiative for freshers like you, right? Like today's batch or 2025 batch, which I am teaching, that they should know about some basics of backend development, how the scalability happens, how the system design architectures, right? What are the different components of backend development which are involved in system design, such as load balancers, rate limiters, API gateways, right? And then we can say scalability algorithms, right? And many more, right? We have caching, right? We have different kinds of architecture such as event driven, we have messaging queues, we have so many things, right? We are not just when we go to corporate world, we are not just limited to DSA, DBMS or OOPS and OS, right? So these are the basic things which everybody does. But what we need to do today, right? Because today the competition is really high, right? So we need something extra edge, right, from the students. So what we need is, we need something extra like the basics of system design, such that you can stand above the other competition, right, above the other students. So this slides or this material is prepared by me. Obviously this is not prepared wholly by me, obviously I have copy pasted it from some other sites. But yes, after you have this material, you would not be requiring to refer like Geeks for Geeks. We have material here from Geeks for Geeks. From Medium, I have picked up some material from different sites, right? You don't have to traverse each and every site, right? So you will be getting this PPT when we'll be starting with backend development basics, right? And for each lecture, I will be providing the PPT and with the related slides, and you can refer these, right? So these slides will help you even when you go into the industry and survive it there for 2 to 3 years even, right? So this will help you really, because these are basics and this should be known by at least experience 1 year experience engineers, right? But I'll be teaching in you guys in such a way that you don't need anything else, right? You will not be bounded to a particular language, that is C++ Java. These are whole concepts, right? Obviously we will be building some demo project, right? uh, like how the things work, how the latest technologies like Kafka, Elasticsearch works, right? I will be doing that in Java. But before that, I will be taking all students into consideration who don't even know Java, who do everything in C++ or Python, right? I don't care, right? I will be teaching each and everything irrespective of your language, because these are just concepts which are just agnostic of the language, right? They are universal concepts. So I hope like after we are done with this, then you have the strength to bear this, right? So it's really interesting topic, I would say that, right? So let's start with the previous what we did yesterday was relational databases, right? Let's just have a quick recap. Okay, so what were relational databases, right? So relational databases, we did ER diagram also. I don't think that needs a recap, right? Because that is pretty simple. But from now the main content of the DBMS starts, right? So relational databases are a type of databases which stores and organizes data in a structured way, right? And data obviously is stored in form of rows and columns, right? Each row has a unique key which is used to identify that row, right? So basically, how many kinds of database do we have right now? We have two kinds of databases, that is SQL and NoSQL, right? What we learned yesterday is that SQL is a structured query language and NoSQL is not only SQL, right? That is non-structured query language basically. So databases, SQL databases are also known as relational databases, as we read yesterday. Similarly, NoSQL databases are known as non-relational databases. SQL databases have predefined schema. Data is stored in tables, right, of rows and columns. But here in NoSQL databases, we don't have a predefined schema. When we don't have a predefined schema, that means the schema is flexible, right? So they use JavaScript object notation, that is JSON, or they even use key value pair to store the data, right? So these were the basic differences between SQL and NoSQL. Then we did was SQL advantages and disadvantages, right? So what are the advantages of SQL? Basically, the advantage is that it has a predefined schema or it has a fixed structure, right? So if it has a fixed structure, it is ideal for those scenarios where your database is not changing frequently. Now, because of its fixed schema, it supports various properties such as asset properties, right? We have complex queries support in SQL databases. I shared you a YouTube video link of Arpit Bihani. You guys can refer that. Why I say that SQL databases support joins really good, right? But NoSQL databases have some complexity when it comes to perform the joins, right? Now, since it is a predefined schema, so it is a rigid schema. So sometimes when we need an entity such that it updates or it changes its properties regularly, then our fixed schema doesn't work or doesn't fit into the picture. Then we need a NoSQL database, right? Because we need to add or remove column on regular basis, right? Now scaling also, right? When we talk about scaling, SQL databases are vertically scalable. What do I mean by vertically scalable? As I told you, that vertically scalable means that you have to increase the size of the data machine, right? Basically, server which you are running your SQL database on. That is, you will increase the size of the server from, let's say, 1 GB, and your user base has increased. Then from 1 GB, you are shifting to a 10 GB machine, right? But in horizontal scaling, the NoSQL databases fits better in that example. Why? Because in horizontal scaling, we don't increase the size, we increase the number of servers with the let's say identical size, right? So rather than shifting from 1 GB to 10 GB, we use 1 GB machines, right? Or 10 1 GB machines, right? Such that we can cater to the use cases, right? So we will get to know about NoSQL databases in a subsequent lectures, but yeah, right now they are the high level differences and advantages and disadvantages, right? I hope the recap is clear to you guys, right? So let's proceed with the asset properties first, right? So asset properties, right? Basically, asset properties, you guys might also know that atomicity, right? Atomicity ensures that a transaction is treated as a single, right, indivisible unit. That means that it either the changes will be committed to a database, or they will not be committed to a database at all, right? Just give me a minute. Let me just open the document. So by atomicity, right? Atomicity. So when we talk about atomicity, we say that if A needs to send 10 rupees, right, to B, and B has initial balance to as 0, then if I say that A credits B rupees 10, so what will happen then? It will not be the case that when A is crediting, let's say, it will be left with 0 rupees. Now B is getting 5 rupees. You are saying I was crediting B with 10 rupees, but somehow due to some issue only 5 rupees were credited. No. If we are saying that a transaction consists of transferring 10 rupees, that means your transaction will be transferring 10 rupees as a whole, will not be transferring partial money, right? That is not atomicity. So atomicity guarantees that your changes are committed as a whole or either rolled back. That means this will not happen. Your transaction will fail eventually, right? So this is the principle of atomicity, right? So you have an example over here. Consider a bank transfer where money is withdrawn from one account and deposited to other, right? So you can have a look over there. This is the same example, just in a theory form. I just have explained it in much easier way, right? Give it a read. Just go through the example, giving you 10 to 15 seconds. Okay. So let's go with consistency, right? So after atomicity, we are dealing with the consistency. That is, your transaction brings the database from one valid state to another, right? So basically, it should satisfy some of the integrity constraints before and after the transaction, right? See, guys, I know like this is something pretty easy for some guys, as you guys might be very well known with the DBMS, but I have to cater to each and every student, right? Some of you might not know this or might have some difficulty with the examples which are taught in the class. So my responsibility is to like give you guys or give cater everyone, right? So please support each other in this thing, right? Don't be like, I know this, I don't want to read this, right? Please shift to another slide. No, this will not happen, right? Okay, so consistency means that when you were transferring, right, when you were transferring your money from A to B, what was the total amount over here? The total amount of A plus B was 10 rupees, right? A plus B was 10 rupees. Now when I am saying that I have already credited to B, right, I have credited B to rupees 10, let's say this, it will happen like 10. Now A plus B should also be equal to 10 after that, right? So this is one valid state from one valid state to another, right? There should not be discrepancy in the amount, in the total amount changed, right? Your total amount remains the same. However, your individual amount is varying, right? So you have an example over here in the theoretical part, right? So has a constraint that ensures the total balance of account is always constant, right? If your transaction violates this constraint, right, your transaction will be rolled back, right? It should not be happening like that. Okay. Now talking about the isolation after the consistency, right? So isolation basically ensures that your transaction is isolated from another operations executed by other transaction, right? What it means to say is, if taking the same example, now there are different levels of isolation which we will be learning, right, in the subsequent lectures. But if I'm sending 10 rupees to B, right, if I'm sending 10 rupees to B, and you are saying that hey, C is there, C is there, and it also is sending 10 rupees to B, right, 10 rupees to B. But when it read the, now how will it send 10 rupees to B? First it read the balance, let's say C first read the balance of B, and then it is sending to B, right? Then it is sending 10 rupees to B. So what it did was, it read that B's initial balance was 0. B's initial balance was 0. But somehow for this transaction T1, what happened was, now this is transaction T2, right? T2. Now while your C read the state of B, this transaction T1 updated the state of B, that is 10, right? 10. Now you can see here A just read, here A just read B to be 0 and it updated the B. But here the C was seeing that B state is 0. So this is a discrepancy, right? This is a very weak isolation level. That is, your transactions can intersect with each other. So this should not happen. Your B should have a final amount that is only 10, right? Because your C is updating B, right? So basically your transactions should not be interfering with each other, right? Your transactions should not be interfering with each other such